All right, day 2, we're going to finish up the paper from yesterday. No new problems today. Hopefully you already watched yesterday's video. If not, go back and watch that, the one from the 13th. Hope you're having a happy Friday. Miss Emerson, I believe, is stopping by. She will help you guys get signed in to this class for VU so you can get your college credit, get that associate's degree for most of us. And let's go ahead and talk function composition, okay? So function notation is another way to write y equals. Now, in function notation, instead of y equals, we often see it something like this. We briefly talked about this yesterday. F of x equals 2x plus 3, okay? We have some x value that's our input. X is considered the input. That results in our output, or our f of x. The reason f of x is the output is because as x changes, it causes f of x to be different depending on the equation or the function. So if we look here, we have a function here, f, which is defined as f of x equals 2x to the third minus 3x minus 2. If we look here, f of 3, okay, we got to think about what that means. So instead of f of x, now it's f of 3. That means everywhere there is an x, we're going to replace it with a 3, okay? So f of 3 is going to equal, and if we look here, it's 2 times, instead of x, it's 3 cubed, okay, minus 3 times 3, and then minus 2. Now, PEMDAS is very important when we do this problem. We have to remember parentheses. We look in there, nothing's going on, just 3. Okay, exponents, so 3 to the third here, that becomes 27. So we're going to have 2 times 27, okay, minus 9, minus 2. Okay, then multiplication, we get 54 minus 9 minus 2. And our end result, 54 minus 9. Okay, so then we're at, what, 45? And then minus 2 gives us 43. That would be the results of this f of 3. Okay. Now, part B here is slightly different. Instead of f of 3, it's now 3f of x. Now, if we think about that, if we know that f of x is 2x cubed minus 3x minus 2, 3f of x is just we take this entire thing and we times it by 3. So 3 times whatever f of x was. And then we can just distribute that, and we're left with 6x cubed minus 9x minus 6. Okay, final one, part C, f of negative x. That means everywhere there was an x, we're going to replace it with a negative. So we've kind of done this already when we talked about negating it. So think for a moment, if it is true that we could replace x with negative x, and it ends up being the same, that would mean that it was symmetric over the y-axis. Now on this particular one, it ends up not being the same. When we take negative x to the third, it comes out to negative x to the third, so this will be negative 2x to the third plus 3x minus 2. As you can see, that's not the same, which means this is not symmetric over the y-axis, if we think back to chapter 0. All right, at the bottom, we got 6 more problems we're going to look at here. We got our 2 functions. F of x is x squared minus 2. G of x is 4x squared minus 3x. So this first one, 2 times f of negative 3. Now we have to remember our order of operations here. We're going to deal with f of negative 3 first, and whatever we get, then we're going to times it by 2. So 2 times, and f of negative 3, remember we're using this value of f now, f of x. So it is what? Negative 3 squared minus 2. So negative 3 squared, that gives us 9 minus 2. And then we get 2 times that 7. And our final answer will be 14. All right, now the second one here, 2b. This is different. It says f of x equals 14. So we know f of x right here is x squared minus 2. We're saying if x squared minus 2 equals 14, well, let's go ahead and solve that. Let's solve for x. So to do that, we'd add 2. X squared is going to equal 16. At this point, we take our square root of both sides. Now, do we remember? When we add the square root, that means we have 2 answers here, plus or minus 4. All right, part C, g of negative 2x. So we use the g of x, but everywhere there's an x, we replace it with a negative 2x. All right, we square it. 4 times 4x squared. Negative 3 times negative 2x is going to be plus 6x. And in the end, we get 16x squared plus 6x. All right, 3 more. F of x plus 4. So in this one, everywhere there's an x, remember we're using that x squared minus 2. So we're going to take x plus 4 squared minus 2. Okay, for this one, x plus 4 squared, this one is probably where people will make mistakes on this problem. X plus 4 squared does not mean x squared plus 4 squared. It means x plus 4 times x plus 4. So if we follow FOIL, if you've heard that, x squared plus 4x plus 4x and then plus 16. Don't forget, right here there was a minus 2 at the end. And we combine our like terms, we have x squared plus 8x plus 14. All right, 2 more. G of negative 3 minus f of 5. We can solve for both g of negative 3 and then f of 5, and then we'll just subtract them. So g, if you don't remember, up here, 4x squared minus 3x, so that'll be 4 times that negative 3 squared. Then it's minus 3x, so minus 3 times minus 3. Let's go ahead and solve that first. So 4 times 9. Negative times a negative plus 9 here at the end. So we end up with 36 plus 9. That gives us 45. Okay, we're also going to do f of 5. So that was f of x was x squared minus 2. So in our case, we'll get 5 squared minus 2. 25 minus 2 is 23. But then we need to subtract them. So 45 minus 23, that ends up with 22 as our final answer. And we've got one more problem here to look at. F plus g of x. It could be written like this. You also might see it written like this. F of x plus g of x. Okay, this means the exact same thing. So f of x was x squared minus 2 plus g of x is 4x squared minus 3x. At this point, we combine our like terms. We look, we have 1x squared and 4x squared. That gives me 5x squared. Okay, minus 3x minus 2. Okay, so 5x squared minus 3x minus 2 is what I got. So go ahead. If you didn't finish yesterday's, finish that up. You've watched this video, let it stop, and you'll be done. Hope you guys have a great weekend, and I'll see you Monday. Bye.